Hey everyone, today I'm going to show you how to transform a regular point cloud viewer into a virtual surveyor tool with a dash of computer vision mainly. Building on my previous tutorial on artificial intelligence tools for custom object detection based on reality capture data, this time we're taking it up a notch. Learn how to teach your PC to read text from images through computer vision and leverage it for seamless plan generation in AutoCAD Civil 3D. As a point cloud viewer, I'm going to use the Leica Cyclone ENTERPRISE platform with the Leica TruView live web browser viewer. If you're not familiar with Leica Cyclone ENTERPRISE, it delivers a simplified management and collaboration platform. Powered by Leica GIS system JetStream technology, Cyclone ENTERPRISE facilitates reality capture project management, control user and data management features from a simple online browser-based administration portal. Secure, flexible self-management deployment so you can meet your unique IT needs. Provide secure access to internal and external users on a per project basis. No data leaves the premise. Sessions are managed centrally and remotely. You can assign different roles to users with different abilities. Access to rich full 3D reality capture data through desktop programs and web browsers, point clouds, imagery, models, and more. Interoperability with all major CAD products from Hexagon, Autodesk, Bentley, and others via CloudWorks and JetStream powered by technology, delivering rich reality capture-based feature extraction and analysis workflow. My favorite advantage of this server-based approach is that you can store all your vast amounts of data in a single space and access it easily through your browser desktop viewer or CAD software without downloading it. The JetStream technology streams the data directly from the server to your device. To extract coordinates from this browser viewer, we'll need to create some custom scripts. For that, I will use the Python language and PyCharm software. PyCharm is an integrated development environment specifically designed for Python development. Let's install PyCharm. You can download the free community version from this link. I will use the version for Windows. After installation, create a new project and specify the location for it. When you open the new project, you will see that virtual environment will be created. By default, there will be a main script, which you can run just to check that everything is working. To use models for computer vision, you need to install some libraries. For installation, go to Terminal window and type the following commands. Pip install OpenCV Python, used to install the OpenCV libraries for the Python programming language. OpenCV is open source computer vision, provides a wide range of functionalities and tools for image processing and computer vision. PyAutoGUI is a model that provides functions for programmatically controlling the mouse and keyboard. PyScreenshot, a model that provides a simple interface for taking screenshots programmatically. Pillow, powerful image processing library. NumPy, library for numerical and mathematical operations in Python. Also, you need to download and install Tesseract separately. Tesseract is an open-source optical character recognition engine developed by Google. OCR technology is designed to recognize and extract text context from images and scan documents. You can download the Windows version from here. While installing, please remember the path of the installation folder. You will need it later. To use Tesseract from any location, in the command prompt, you can add the Tesseract installation directory to the system path environment variable. To do that, go to Environmental Variables menu. Under System Variables, find the path variable and click Edit. Click New and add the path to the directory where Tesseract is installed. Click OK to close the window. Go back to PyCharm terminal and type pip install Tesseract command. Be sure that in your Python project folder, PyTesseract will be installed. To perform a simple test and ensure everything is working, follow these steps. Create screenshot with any text. Save the image into your project folder and run this script. This script uses the Tesseract OCR engine along with the PyTesseract and Pillow libraries to extract text from an image. Let's break down the script step by step. So first step, it's import libraries. Second step, it's open image. Third, specify Tesseract command path. The path to Tesseract executable specified. Make sure to provide the correct path to the Tesseract executable on your system. Extract text from the image and print the result. If you run it, you will see in the console that the text from your image will be recognized and extracted, which means everything is working. Next, we should teach the program to take a screenshot of the desired area and save it as a file. To define the area, we will use the coordinates of your screen. You can extract the coordinates using the simple script below. This script waits for 2 seconds to give the user time to position the mouse cursor, and then it brings the current coordinates XY of the mouse cursor on the screen. You need to get the coordinates of the left upper corner and right bottom corner to define the area for a screenshot. Add these coordinates to the below script. Run the script and test that it's working fine. You can also check the captured screenshot by opening the image PNG file. As the next step, I decided to modify the script to keep only numerical values and save all extracted coordinates into a TXT file. To make it faster, I created one more script for hotkeys. It runs the previous script by pressing a specified key on the keyboard and assigns different names to the coordinates. Name codes are based on the description key set parameter from AutoCAD Civil 3D. Description key set is a set of rules or instructions that defines how survey data, specifically points, is translated or converted into objects within the Civil 3D environment. If you use codes from this description key set, then when you import your TXT file into Civil 3D, all objects will be generated automatically based on the rules from the description key set. I already demonstrated this approach in my previous tutorial about raw feature extraction in Cyclone 3D software. So I decided to assign the below codes to the hotkeys. Of course, you can change these namings or assign another hotkey, just make sure that these keys are not already in use by default in the software. To understand which points were extracted, I decided to create another script that will generate a GeoTag at each extracted point. The script should also assign related names and categories to the GeoTag for easily management. For that, we can use a Python module that provides functions for programmatically controlling the mouse and keyboard. The new script allows the user to define specific action associated with certain keys. When a defined key is pressed, the script performs a series of mouse and keyboard actions, including running external script, find PY, and interacting with specific areas of the screen. The script is set up to be responsive to specific hotkeys and demonstrates basic automation capabilities. The find PY script performs image-to-text conversion. The hotkeys 3PY script is in charge for hotkeys. Note that the script relies on specific screen coordinates, and you may need to adjust them based on your application user interface. All final scripts can be downloaded below. Now all GeoTags are generated in the specified location automatically by pressing the related hotkey. If you stream this point cloud to desktop Leica TruView, you will be able to colorize and filter them by category. Point coordinates can be extracted in 3D point cloud view or in image panoramic view. A text file is generated simultaneously, so after finishing, you can import it into your CAD software and all icons will appear automatically. You may ask why this is needed if I can just import a point cloud into my CAD software and start generating drawings there based on the point cloud data. I agree, that's easier, but imagine a scenario where you have 20-30 drone engineers in your organization and all of them should work on a big project around maybe 2-3 GB of data. So first reason could be data size. If you're working with the file-based approach, it means all users should store the file on their own PCs. This implies that 20 users will hold 4 TB of data on their PCs. With the Leica Cyclone ENTERPRISE server-based approach, they can simply open this data via browser or desktop viewer and use only server storage to keep this data. An additional benefit is that everyone will use a single source of information. You can share links to this project with stakeholders outside the organization, allowing them to view the data online without downloading it. Second, it's data management. If you're going to split project between your engineers, you will likely be forced to segment the point cloud by blocks or create some borders for each user to let them work with specified regions to avoid duplication of the extracted feature. All these operations will take additional time and may lead to inconsistencies in recording measurements and details over time or across different observers. With the latest point cloud processing software like Register 360 Plus 2023.1, you can easily divide the whole area into multiple limit boxes, and information about these limit boxes will be published to the Leica Cyclone ENTERPRISE server. This means that each user can work with the related limit box only. If someone prefers to use a tablet in the field to collect asset information for GeoTags, then they can easily merge all collected data with existing project in the Leica Cyclone ENTERPRISE server. Sometimes, even if you have 20 engineers within your organization, it doesn't mean that all of them have licenses for software. Perhaps they are using 10 floating licenses when they are available. That means you will be forced to invest additionally in extra licenses. If the user is not familiar with point cloud processing, it will take additional time to train them. Leica Cyclone ENTERPRISE allows connecting an unlimited number of users via a free Leica TruView viewer with a very simple and user-friendly interface. Computer specification. Even if you provide all your engineers with enough software licenses, it doesn't mean that all of them have suitable computer specification to handle a 2 or 300 GB data in the software. That will force you to spend additional investment on computer upgrades. With Leica Cyclone ENTERPRISE, if you open the project via browser, then all computing will rely on server resources. That means end users don't need to have powerful PCs to work with this data. It can be opened even via tablet. As you can see, for big projects or companies with a large number of employees, division or stakeholders, this server-based approach is must-have. And keep in mind that if it needed, you can stream the reality capture data from the Leica Cyclone ENTERPRISE server to your CAD software via Leica Cloud Workspace.